Hello my dear students, myself Vishal Virani and today we are discuss about the class 12 statistic part 2 lesson number 1 and lesson number 1 is that probability. Okay, so in this lecture today we are discuss about the mathematical definition of the probability. Okay, now we are going to give the definition of the probability and which type of mathematical definition of the probability. Okay, before discuss about the mathematical definition of the probability, we have to know about the term is that equiprobable event and second one is the favorable outcome. Okay, first one is the equiprobable events and second one is that favorable outcome. Okay, so first one is the equiprobable event. What is the meaning of the equiprobable events? As the name suggests, equiprobable means equal probability. Yes, which events has a equal probability, then those events are called as the equiprobable events. For example, if we toss a balanced coin, yes, then our possible outcome will be H and T. H and T means head and tail. Yes, if we toss a balanced coin, then our possible outcome will be head and tail. Yes, the probability of the head is 50% and also the probability of the tail is also 50%. Yes, so there is a equal probability of head and tail. Yes, so this event is called as the equiprobable event. Okay, next example is that if suppose there is a match in between two teams, Australia and India. Yes, then what is the probability of winning of India and what is the probability of winning of Australia? 50-50%. Yes, so this event is also called as the equiprobable events. Okay, and the third example is that if suppose in one classroom there is a two girls and two boys. Yes, two girls and two boys. Yes, then the probability of the selection of the student from this class, probability of the selection of the student from this class of male is that 50% and the probability of the selection of girl from this class is also 50%. Why? Because the number of the girl and boy in the class is same, two boys and two girls, so the probability of the selection of girl and the probability of the selection of boy will be same. Yes, so this event is also called as the equiprobable events. Clear? Okay, now if in the class there is a three boys and two girls, so the probability of the selection of boy is more than the probability of the selection of the girl. Why? Because in classroom there is a three boy and only two girls. Yes, the number of the boy is greater than the number of girl. Yes, so that the probability of the selection of a boy is greater than the probability of the selection of a girl. Yes, so this event is not called as the equiprobable events. Yes, okay. Equiprobable events. If there is no apparent reason to believe, that out of one or more events of a random experiment, any one event more or less. Yes, there is no reason to define that one event is more or less. Yes, okay. जो कोई भी इवेंट है तो ये इवेंट ज़्यादा होती है कि कम होती है, उसके बारे में अब हमको पता नहीं है, तो उस इवेंट को हम क्या कहते हैं? इक्विप्रोबेबल इवेंट कहते हैं. हमने एग्जांपल दिया है ना कि क्लासरूम में दो गर्ल है और दो बॉय है, तो दोनों की प्रोबेबिलिटी कितनी होगी? 50-50%. यस, 50-50% सिलेक्शन ऑफ द बॉय एंड द सिलेक्शन ऑफ द गर्ल. Probability of the selection of the girl and the probability of the selection of boy will be same when the number of boy and number of girl will be same. Yes, but when the number of boy is greater than the number of girl, then the probability of the selection of boy is greater than the probability of the selection of girl. Clear? So here in this case probability of number of boys will be more than the girls. Yes, so it is more. Yes, and the probability of the girl is less than the probability of the boy. Why? Because the number of girls in class is less than the number of boy in the class. Yes, so if there is no apparent reason to believe that out of one or more event of a random experiment, any one event more or less. Yes, from this example we can see that the number of boy will be more and number of girl will be less. Yes, any one event is more or less likely to occur than the other events, then the events are called as a equiprobable event. Okay, we understand by giving one example. Example 1 is that a manufacturer of a certain item has two machine M1 and M2 in his factory for the production of item. Both machine produce same number of item. Yes, both machine are produce same number of item during a day. The lots are made of the produced good by probably mixing the item produced on both the machine during a day. Yes, we have to mix the production of the item of both machine M1 and M2. Yes, an item randomly selected, such a lot is made on machine M1 or M2. M1 or machine M2 are the elementary events which are equiprobable. Yes, there is a two machine and both machine produce same number of item. Yes, if machine 1 is produce 100 item per day and machine 2 is also produce 100 item per day, or now mix it, okay, and we have to select the one item from the mixing of the production of the item of machine M1 and M2. Okay, so the probability of the selection of the item is same. Yes, probability of the selection item is the same. Yes, which will be 50-50%. we जो कोई भी हमने आइटम सिलेक्ट करी है वो मशीन M1 और M में से होगी, उसकी प्रोबेबिलिटी कितनी है, सेम है, क्योंकि यहाँ पे जो हमने प्रोडक्शन किया है आइटम का दोनों मशीन में से वो कैसा है, सेम है. क्लियर? ओके, सो देयर इज अ सेम नंबर ऑफ आइटम, सो द प्रोबेबिलिटी विल बी सेम. यस, सो दिस experiment, these events is called as a equiprobable events. Clear? Okay, now second example is that there is a two wheel A and wheel B. Okay, and on wheel A and wheel B there is a three number will be marked 1, 2 and 3. Okay, but from the wheel A, if we select any number out of this three number 1, 2 and 3, so the probability of the selection of the one number is same. Yes, because it is divided by equally. Yes, 33% and 33%. So this event it is called as the equiprobable events. Okay, but in the wheel there is also three number 1, 2 and 3, but the division is not same. There is a no equal part of the number 1, 2 and 3. There is a equal part of 1, 2 and 3. So this is a equal probability events. Yes, but this is not equal probability event. Yes, here we can see that the selection of number 3 has a more probability. Yes, and the selection of the number 1 has a less probability. Yes, and selection of a number 2, probability of the selection of the number 2 is in between the selection of the probability of the selection of number 1 and number 3. Yes, probability of the selection of number 3 is more. Yes, probability of the selection of number 1 is less. Yes, and the probability of the selection of number 2 is in between the probability of the selection of number 1 and the probability of the selection of the number 3. Clear? So this is not a equiprobable event, but this is the equiprobable events. Okay, example 2 is that the wheel A and B marked with the number 1, 2, 3 as shown in the following pictures are rotated by hand. This is rotated by hand. The number against the pointer is noted down when the wheel stop rotating after some time. Yes, okay, then it is clear from the picture that all the three numbers on wheel A will come against the pointer are equiprobable events. Yes, because there is a equal part of the wheel A. Yes, and there is a no equal part of the wheel B. Yes, but the number 1, 2, 3 coming against the pointer for wheel B are not equiprobable events. Clear? Okay, write down write down it is the equiprobable events. Okay, now we are come on to the favorable outcomes. We already discussed about the favorable outcome in a previous lecture. What is the favorable outcome? There if any event will be occur, then there is a many possible outcome. There will be many possible outcome. For example, if we toss a balanced coin, so in this case there is a two possible outcome, head and tail. Yes, but we can't say that which outcome will become. Yes, but we can't say which outcome will be come, head आएगा कि tail आएगा, वो हमको पता नहीं है. Clear? So which outcome will be obtained from the possible outcome, it is called as a favorable outcome. ओके तो पॉसिबल आउटकम में से कौन सा आउटकम आएगा वो हमको पता नहीं है. तो पॉसिबल आउटकम में से जो कोई भी आउटकम आता है उस आउटकम को क्या कहते हैं? फेवरेबल आउटकम कहते हैं. क्लियर? ओके चलो, डेफिनेशन इज दैट इफ द सम आउटकम आउट ऑफ सम आउटकम, yes, out of all elementary outcome, all elementary outcome is all possible outcome. Yes, if some outcome out of all possible outcome or out of all elementary outcome in a sample space of a random experiment indicate the occurrence of the certain event A, we give the event name and the event name is the event A. Suppose if we toss a balanced coin, yes, then our possible outcome will be head and tail. Our possible outcome will be head and tail. Suppose if we give the name event A as a getting head on the coin, yes, event A is the getting head on the coin and the event B as the getting tail on the coin. Yes, so the event A is the getting head on the coin. Yes, and head is the our favorable outcome. Yes, out of the possible outcome, H and T. Yes, so the event A, element of the event A is the head and the element of the event B is the tail. Yes, okay, so element of the event A head and the element of the event B tail, it is called as the favorable outcome. Yes, and this favorable outcome, it is from our possible outcome. Clear? If some outcome out of all elementary outcome in the sample space of a random experiment indicate the occurrence of a certain event A, then the outcome are called a favorable outcomes. Okay, for example is that a card is drawn from a pack of 52 cards. Yes, we have to select a card from out of the 52 cards, and if event A, we give the name event A. If the event A did not take, the card drawn is a free card. Yes, card drawn is a free card. Okay, in this case, what is the how many is the possible outcome? How many is the possible outcome? Possible outcome is the 52 cards. Yes, and event E is the selection of the face card. Yes, selection of the face card. And how many face card are available in the 52 cards? Yes, it will be SK, DK, CK, HK. S means space, D means diamond, C means club, and H means heart. Okay, so this is the king. K means king of the spade, king of the diamond, king of the club, and the king of heart. Then the queen of spade, then the queen of diamond, queen of club, and queen of heart. Yes, then jack of the spade, jack of diamond, jack of club, and jack of heart. Yes, this is our face card. Yes, out of these 52 cards. Yes, so this is called as a favorable outcome. And how many it will be? It will be 12 outcome out of the 52 possible outcome. Yes, event A is denote that the card drawn is a face card, then the set of favorable outcome is follow. Yes, this is a set of the favorable outcome. How many it will be? Favorable outcome will be 12 and our possible outcome will be 52. Clear? Okay, done. Okay, now we are discuss about the mathematical definition of the probability. Okay, so the definition of the probability is that the ratio of the number of favorable outcome and the number of possible outcome. Yes, probability is the ratio of number of favorable outcome and number of possible outcome. Clear? So that the mathematical definition of the probability is that suppose there are total n outcome. Yes, total n outcome. There is the number of possible outcome is n. Yes, in the finite sample space of random experiment, which are mutually exclusive, yes, exhaustive and equiprobable. Okay, so there is a total possible outcome is the n. Yes, and if m outcome among them are favorable, yes, and the favorable outcome is m, number of the favorable outcome is m, and number of the total possible outcome is n. Yes, and if m outcome among them are favorable for an event A, and event A has a favorable outcome and the favorable number of the favorable outcome is m, yes, then the probability of the event A is the m by n. Yes, m by m, probability of event A is the m by n. What is the m? M is the number of the total possible, m is the number of the total favorable outcome, yes, and n is the number of total possible outcome. Clear? So probability is denoted by P of A. P of A means probability of event A. P of A means probability of event A. Yes, so P of A is equal to probability of event A. Yes, and is equal to favorable outcome of event A. Yes, m by n means m means the favorable outcomes of event A. Yes, and what is n? Yes, n is the outcome in the finite sample space of random experiment which are mutually exclusive, exhaustive and equiprobable. Okay, so n is the total number of mutually exclusive, exhaustive and equiprobable outcome of the sample space. Yes, so P of A means the probability of event A is equal to m by n. Yeah, what is the probability? Probability is the ratio of number of favorable outcome and number of possible outcome. Okay, both the number m and n, yes, is greater than 0. Yes, our number of the possible outcome and number of the favorable outcome is always greater than 0. Yes, are integer and m is always less than or equal to 1. Yes, what is the m? What is the m? M is the our favorable outcome and n is the number of the possible outcome. Yes, and we know that always number of the favorable outcome is less than or equal to the number of our possible outcome. Why? Because now our favorable outcome is the part of the possible outcome. Yes, is the part of the possible outcome. For example, if we toss a balanced coin, yes, then the number of possible outcome will be, then the number of possible outcome m is equal to 2. Yes, and which is, it is h and t. Yes, it is the our possible outcome. Yes, it is n possible outcome is denoted by n. Okay, so n is equal to 2 when if we toss the balanced coin, then we get the total number of outcome is equal to 2 and it will be head and tail. Yeah, but our favorable outcome, when we toss a balanced coin, then we only get head or tail. Yeah, so the number of favorable outcome m is equal to 1. Yes, m is equal to 1. It is either head or either tail. Clear? So this is the our total possible outcome and this is the our favorable outcome. Yes, and here we can see that the number of the possible outcome is 2 and number of the favorable outcome is 1. Yes, so always number of favorable outcome is less than or equal to number of possible outcome. Clear? Okay, now n can't be 0 and infinite. Yes, n can't be 0 and infinite. Number of possible event can't be 0 or infinite. If number of the total possible outcome is 0, then m upon 0. So the probability of event is infinite. This is not possible. Okay. If n is equal to infinite, if we put n is equal to infinite, then m upon infinite is equal to 0. So the probability of event A is equal to 0. So we assume that n can't be 0 and infinite. Okay. Now mathematical definition of probability, it is called as a classical definition. Mathematical definition is also called as a classical definition. Why classical definition? क्लासिकल डेफिनेशन मीन्स प्राचीन डेफिनेशन, ये जो मैथमेटिकल डेफिनेशन है वो बहुत पुरानी है, तो इसलिए मैथमेटिकल डेफिनेशन को हम क्लासिकल डेफिनेशन कहते हैं। क्लियर? सो टू understand the mathematical definition of the probability, we have to take some assumption. Yes, the assumption of the mathematical definition are as follow. Yes, this is the assumption to give the mathematical definition of the probability. Clear? First assumption is that the number of outcome in the sample space of random experiment is finite. Yes, number of outcome in a sample space. Yes, which is it? Total number of possible outcome. Total number of possible outcome is finite or infinite? Finite. It should be finite. Okay. Yes, it should be finite for give the mathematical definition of the probability. Okay. Then second assumption is that the number of outcome in sample space of a random experiment is known. Yes, and we also know the possible outcome of the random experiment. Yes, either if it was a balanced coin, yes, then we know the total number of the possible outcome. Yes, means it is finite. It is finite. Yes, and also we know the total possible outcome means the element of the sample space. We also know the element of the sample space, and there if it was the balanced coin, then our possible outcome will be H and T. Yes, so we also know the possible outcome of the random experiment. Yes, the number of outcome in the sample space of random experiment is also known. Done? Okay. Third assumption is that the outcome in a sample space of a random experiment are equiprobable. Yes, we discussed about the equiprobable. Okay, so that the outcome in the sample space of the random experiment are the equiprobable. Equiprobable means if it was a balanced coin, yes, then probability of getting head on the coin is 50%. Yes, and getting tail on the coin, probability of getting tail on coin, it is also 50%. Yes, so here we can see that the probability of getting head and probability of getting tail is same 50-50%. Yes, so this event is called as the equiprobable events. Yes, so to give the mathematical definition of the probability, our event will be equiprobable event. Yes, so this is the three assumption to give the mathematical definition of the probability. Okay, now we are coming to the important result about the probability are as follow. Okay, now we are coming to the result of the probability. Okay, first result is that range for the value of probability P of A. Yes, there is a event A and the probability of event A is denoted by P of A. Yes, so what is the range of the probability of event A? Yes, okay, so what is the range of the probability of event A? Range of the probability of event A is 0 to 1. Yes, 0 to 1. So we can write as 0 less than or equal to P of A and less than or equal to 1. Yes, probability of event is not less than 0 and not greater than 1. Yes, if event will not happen, event will not happen, yes, then the probability is 0. Yes, and if event will be 100% happen, then the probability of event is 1. Yes, and if we don't know event will be happen or not, yes, then the probability of the event is in between 0 to 1. Yes, understand? So the range of the probability of any event P of A is in between 0 to 1. Yes, now second result is that probability of impossible event is 0. Yes, probability of impossible event is 0. यस कि वो इवेंट होने ही नहीं वाले, तो उसकी प्रोबेबिलिटी कितनी होगी? P of phi इज इक्वल टू 0. क्लियर? सपोज सन है, वो वेस्ट से राइज होगा, तो उसकी प्रोबेबिलिटी कितनी है? 0%. वो वेस्ट से राइज नहीं होगा, वो कहाँ से राइज होगा? वो ऑलवेज ईस्ट से राइज होगा. क्लियर? सो द प्रोबेबिलिटी ऑफ द इम्पॉसिबल इवेंट इज 0. ओके, देन third result is that the probability of certain event सर्टेन इवेंट्स मीन्स ये इवेंट होती है, चाहे कुछ भी हो जाए ये इवेंट होके ही रहती है. ओके, तो ये इवेंट 100% होती है, 100% में होती है मीन्स द पॉसिबिलिटी प्रोबेबिलिटी ऑफ द सर्टेन इवेंट्स इज 1. यस, सो P ऑफ U इज इक्वल टू 1. लाइक एज सन है वो ईस्ट से राइज होता है. यस, तो वो ऑलवेज ईस्ट से ही राइज होगा, वो वेस्ट से राइज नहीं होगा. क्लियर? सो सन है वो ईस्ट से राइज होगा, उसकी प्रोबेबिलिटी कितनी है? 100%. मीन्स द प्रोबेबिलिटी ऑफ दिस इवेंट इज अ सर्टेन इवेंट, सो द प्रोबेबिलिटी ऑफ दिस इवेंट इज इक्वल टू 1. Yes, okay. Now the probability of the complementary event A dash. Yes, A dash is the complementary of the event A. Yes, the probability of the complementary event A dash of event A in the sample space U is P of A. P of A means the probability of the complementary of event A is equal to 1 minus probability of the event A. Yes. For example, if we toss a balanced coin, yes, then our event A is the getting head on the possible coin. Suppose our event A is the getting head on the coin. Yes, so probability of event A is 50%. यस, कि कॉइन पे हेड आने की प्रोबेबिलिटी कितनी है? 50% है. तो उसका उल्टा सोचो, उल्टा क्या है कि कॉइन पे हेड नहीं आने की प्रोबेबिलिटी कितनी है? कॉइन पे हेड नहीं आने की प्रोबेबिलिटी, तो ये क्या हो गया? और कॉम्प्लीमेंट्री ऑफ इवेंट है, कॉम्प्लीमेंट्री ऑफ इवेंट है, तो कॉइन पे हेड नहीं आने की प्रोबेबिलिटी कितनी है? वो भी 50% है. यस, क्योंकि क्या आ सकता है? हेड नहीं आएगा तो क्या आएगा? टेल आएगा. क्लियर? सो द प्रोबेबिलिटी ऑफ कॉम्प्लीमेंट्री इवेंट ए डैश इज इक्वल टू 1 माइनस प्रोबेबिलिटी ऑफ इवेंट ए. यस, नाउ रिजल्ट 5 इज दैट इफ ए इज सबसेट ऑफ बी, A is the subset of B, means A is the part of B. Yes, for two events A and B in the sample space of a random experiment, then P of A is less than or equal to P of B. Yes, A is the subset of B, means A is the part of B. Yes, probability of B is more than probability of A. Probability of B is more than probability of A. Yes, okay. Now second one is that probability of B minus A is equal to probability of B minus probability of A. Okay, write down it. Okay, now sixth result of the probability is that suppose if two events A and B in the sample space of random experiment. Okay, so there is a two event A and event B. Okay, so first result is that P of intersection of event A and B is always less than or equal to P of A. Yes, probability of the intersection of event A and B is always less than probability of event A. Why? Because A intersection of A and B is the subset of event A. Yes, we know that intersection of event A and B is the subset of event A. Yes, so that probability of A is greater than or equal to the probability of intersection of event A and B. Yes, we can write as for the probability B. Yes, probability of intersection of event A and B, yes, is also less than or equal to probability of event B. Why? Because intersection of event A and B is also part of the event B. Yes, intersection of event B, it is also subset of event B. Okay, now we are discuss about the union of event A and B. We discuss about the probability of the union of event A and B. Here we are discuss about the probability of the intersection of event A and B. Yes, and now we are going to discuss about the probability of union of event A and B. Yes, probability of union A and B is always greater than and equal to of the probability of event A. Why? Because here A is the subset of the union of event A and B. Yes, A is the part of union of A and B. Yes, and we can write as for B. Yes, probability of event A and B is greater than or equal to probability of event B. Yes, why? Because event A is also subset of union of event A and B. Yes, event B is also the subset of union A and B. Yes, B is also part of union A and B. Yes. Okay, now we are discuss about the probability of intersection of complementary event A and complementary of event B. Yes, and is equal to probability of complement of union of A and B. This is the probability of complement of complement of union of A and B. Yes, and it is equal to 1 minus P of A union B. Yes, if we write P A dash, then we have to write P A dash is equal to 1 minus P of A. Yes, here P of A union B dash means 1 minus P of A union B. Yes, okay. Now P complement of A union and complement of B. Yes, and we can write it P intersection of A and B. Yes, and we have to complement it. Yes, then it is equal to 1 minus P of A intersection B. Clear? Okay. Now P of A minus B, probability of A minus B is equal to P of A and intersection of B dash. Clear? And it is right as the P of A minus intersection of probability of intersection of event A and B. Yes, okay. And then P of B minus A, P of B minus A is equal to P of A dash intersection B and is equal to P of B minus probability of intersection of event A and B. Okay, so this is the our result from the probability. Okay, and last, now we conclude that if the probability is 0, yes, then the probability of intersection of event A and B is greater than and equal to 0. Yes, then the probability of event E is also greater than and equal to probability of intersection of event A and B. Yes, and the probability of union of event A and B is greater than and equal to probability of event A. And the probability of sum of event A and B is greater than or equal to the probability of union of event A and B. Clear? Write down it. Okay, write down it. Done. Okay, so keep practicing and we will meet you in next lecture.